Now, we have a fact about 3 of our 4 connectors that we've kind of alluded to before, but we can make it a little bit more formal in the language of equivalence. And that is that 3 out of our 4 connectors are symmetric. And that's true just because of how we defined them. When we defined them, we said that the conjunction, that's the word and, the symbol that looks like the letter A without the cross piece, that's true when both of the statements being combined are true. So if we go to fill in a truth table for P and Q, we'll say, well, here P is true and Q is true, so P and Q is true. Or we could say Q is true and P is true, so Q and P is true. Here, well, Q is false, so P and Q is false. That also makes Q and P be false. Here, P is false. That makes P and Q be false. It also makes Q and P be false. And here, of course, both statements are false. So the and statement is false no matter what order we write them in. We can do the same thing for disjunction. Disjunction, that's the or statement that we symbolize with that wedge-shaped symbol pointing downward. The disjunction is false when both of the original statements are false. So if we have P or Q, well, both of those are true, so the or is true. If we look at Q first, they're still both true. Here, P is true. That makes P or Q true. It also makes Q or P true. Here, Q is true. That makes P or Q true. It also makes Q or P true. And here, both statements are false. That makes P or Q false. It also makes Q or P false. And then the third statement that we defined symmetrically, so that order doesn't matter, is the biconditional. That's the if and only if. That's the double arrow. That's true when the 2 original statements have the same truth value. If we're looking at P if and only if Q, then when P is true and Q is true, those are the same. They're still the same if we look at Q first and then P. When P is true and Q is false, those are different. They're still different when we look at Q first and then P. When P is false and Q is true, well, those are different. They're still different if we look at Q first and then P. And when they're both false, those are the same. And they're still the same if we look at Q first and then P. Because of the way we defined them, if we switch the order of the simple statements here, well, we get an equivalent statement, right? Because these columns are identical. These columns are identical. These columns are identical. So in other words, for each of these 3 connectors, the and, the or, the if and only if, we can get an equivalent statement just by switching the order. But you'll notice I didn't list all 4 of our connectors, and there's a reason for that. The conditional is not symmetric. Remember that we defined if-then, the conditional. That's the one we symbolized with the arrow going in one direction. We defined that to be false when the first statement is true, but the second statement is false. And of course, if we switch the order, that switches which is the first statement and which is the second statement. So if we make a truth table for if P then Q, well, in the first row, P is true, Q is also true. If P then Q is true. P is true, Q is false. That's when if P then Q is false. P is false, well, if P then Q is automatically true. And again, when P is false, if P then Q is automatically true. What about the other way around? If Q then P is going to be false when Q is true, but P is false. So in the first row, Q is true, P is also true, so that's fine. In the second row, Q is false. Whenever the first part is false, we don't even have to look at the second. The conditional is true. In the third, Q is true, P is false. First statement is true, second is false. That's what makes the conditional false. And then in the last row, Q is false, the conditional is true automatically. So what we notice here is that the second and third rows are different. That means that these statements are not equivalent. If P then Q is not equivalent to if Q then P. It's very important to be aware that we just can't freely switch the order of a conditional like this. And that makes sense, because if we could, then what's going on with our valid and invalid arguments would be very strange indeed. We cannot freely switch the order of a conditional.